has been added. And I can get more information. Diff, except it didn't work. Very occasionally, gdiff does not work. Yeah, it does not work at all. It has something to do with the way that I open the file. There we go. If I open the file in a slightly different way than it's expecting, I'm making this a bit bigger for my benefit at the expense of yours. So I've changed quite a few things in here. It looks like I basically didn't change anything that makes any difference. I just changed colors. So that's something that I should be able to just commit. So if I go back to the status list, make that the only window, and I want to see what I changed in here. Bet you gdiff fails to work. Oh, no, gdiff worked. It looks like I changed almost everything in the file. So I added this comment of solarized text values, and I changed. So basically what I did is I changed all the colors. So same thing. So we can go back to gstatus, and we can say, I want to commit that one. I want to commit that one. And we can go.
Your window manager?
Yes, but at this point it could be any application that you're storing in your home directory. Any application that you care to add to Git that has a text-based config file. Note, there are a lot of things that you don't want to version control in your home directory. Here's a partial listing of them. Actually, the things with exclamation marks are the things I do want to version control, and everything else I don't want. And I think there's a catch-all that by default, anything that begins with a dot I don't want, and then I have to make exceptions. And then I have the same thing in the config directory. So, by and large, anything older you can keep in Git, but anything newer is pain in the butt. So you know how to add files. So I decided that I don't want to keep a to-do file in my home directory. That's something stupid. I should store it in the cloud. So another helpful thing that Fugitive gives us is a gremove command, which will remove the file and the buffer that it's in. So that file is gone, and I can commit that now. Except none of the fugitive commands are available because this is no longer acting in a Git repository. So now we're in a random file that just happens to be in there so that I can run Okay, so that's, we are 16 minutes in? Something like that, 10. So what I'm getting here is, I guess one way you could view this is that I kind of have a GUI for dealing with Vim. Or sorry, for dealing with Git. Because if I run this in the GUI, I have all lines. I mean, this is technically a GUI, isn't it beautiful? It looks much better now, right? There we go. See, it's a GUI. And if I changes in here, there's nothing useful that I can actually change in here. That's a stupid comment to have. That's old code. Don't need to comment about old code. So, see, what I'm trying to think here is what use cases I can show you that are relevant, but without a context, it's kind of hard. So I think that I actually have to digress into a little bit of basics about Git. So there are three conceptual things I probably should have started out with. The first would be a working directory. And you can't see that font either. The first would be the working directory. And the working directory is what we were just playing around in. need a bunch of pre-open terminals. So this is a working directory, and a working directory is like any other directory. It just has a get dir in it. It is defined by what it is not. The next thing you need to know is these are also all locations where files can be. Well, location where objects will be. A working directory is full of objects. In this working directory, there's a bin and a bin directory and a make file. Those are both objects. In Git terms, a directory is a tree, and a file is a blob. What it means to add don't want to discuss implementation details. I just want to discuss what you need to know. So forget that part. An index is files that are prepared to be committed that are changed, which we've previously explained. When you first create a file, it exists in the working directory. So, file is in the working directory, and you run git add, and that moves the file, that adds the file to the index. So it exists in both places. Since it exists in both, I could delete it from the working directory, and it's still in the index. So there's an uncommitted, there's three things that you're seeing here, which I can't actually show you. I can't do, I'm not going to do the Vim Go right now, because right now we are going, if we commit right now, everything that's in the index will get stored into Git, which is a to-do file. The to-do file doesn't actually exist in the file system in the working space directory, in the working directory anymore, because we deleted it. But that change hasn't been explained to Git yet, so that doesn't matter.
So what would happen if you try to commit it?
If I commit, the content of that file already exists somewhere else, so it'll be happily committed. Now, if I look at status, we have no more changes, but we just have a deleted file. But if I recreate the file with different content, and we ask it for a status, it just merely says that it's modified. It doesn't know that it was, officially, Git doesn't even know it was deleted. Only the content has changed. Git doesn't actually even care what the name of that file is, except as content. Because the file, the top of this thing is basically a file with a listing of names in it. That would be the tree. So if we then use gread, which pulls the content back out of the index,
All right, so if you pull the content out of the index, did it just put it in the Vim buffer, or did it overwrite the file?
it did both. It actually, I don't think it overwrote the file. We can check it out. So you can tell that if you see right here, the file is now marked as modified because what's in the buffer is different than what's on the disk. So the G commands edit, talk between your buffer, which is another place where the file exists, and the Git index. It's basically a pipe between the two, where you can push changes. And now if I were to write that's interesting. If I were to write to do as a heading in Markdown, and then write this to the directory, it would still just be modified. But if I were to open the file, type gwrite, delete everything, delete complete the file again, we would once again be in the state where we've modified the file, we're going to commit the modified content, but the file doesn't exist. It doesn't care that it exists. It's really ephemeral, these points where you synchronize. It's like you have a bunch of different copies of the same working directory. So, those are between those two operations is 90% of what you need to manage config files in Git. The other thing, of course, would be commit. Now, what commit is doing is commit is actually doing the part of the Git that you're interested in, which is it is taking what's in the index, and I did A, so it's actually going to commit that change too. It's going to write, when things are committed, what committing means is it means write the change that's in the index, or write the contents of the index to the object database, which gets into more complicated stuff than I care to talk about, but we can take a gander. What you see in front of you is a series of directories. Ignore the PAX directory for right now, and look at the, say for instance, F4. What that is, I believe that's a SHA-256 hash, and that has some file. I think we could look at it. It's, oh no, that was where we can actually see these, which is convenient. All right, so I need to be in the context of this. So we have the status message, which is all fine. We can look at what's it called. We can look at the gdiff, which says that. We can also look at gbrowse. Trying to figure out the best way of showing you commit hashes. It's the git log. So if we look at Git, we're looking at each file. This is the top, and the file name is a bit hard to see, so I can actually echo it. So we're at a very long git hash, and then make file. That's, see, the double slash after the git, this means that's a file that doesn't actually exist. It's a fake file that the Vim plugin is showing us. But that commit hash represents this file at a particular point in time. If we do glog dash, we can actually see a listing of history, and we can see that the information that's been recorded about each commit. This will be the most recent commit, and we can navigate around with C. And in each time you see this, you should be looking at the parent and the tree numbers. Oh, those aren't actually related. So if you actually look at the parent, what you end up looking at is a directory. Now you look at the previous commit. The tree is the directory that the file is in. So this is a listing of directories that are currently committed. I think at this point it would be much better if this was Q&A style. So start asking more questions, Brian.
Why?
Okay, so I'm browsing around and showing you what various blobs look like in Git. This is actually a tree, and it holds a list of blobs. This is now a file that I got to from this tree. A tree is the directory at a current point in time. So if you take the hash of all of these files, that hash represents the directory. And the directory is what gives all of these things names. The tree. isn't going to work without proper Q&A style, I think.
Does anyone else have any questions while Dylan is showing us?
I think that I should have prefixed this with a survey.
Is it easy to branch in with this plugin?
Is it easy to branch? Yes, it is. You actually can do, well, I think you don't, there's no special subcommands for that, but there is this command that lets you execute vim commands. So if I'm looking at this makefile, and I have to have, and one thing that's important to explain, this is kind of a gotcha, I have to be in the context of a file that's known to, that's in a directory. If I'm just in an unnamed buffer, Fugitive isn't active because it doesn't know what directory I'm supposed to be in. So it's a little frustrating. So every time I keep going to this because it's the only visible file in the top level. So I can run git. I don't think there's a, yeah, there isn't a special command for git branch, but if you run git branch, you, for instance, can get a listing of branches. And there's only one. And if you do it, it also knows all of your aliases. So if you do COB test, it will show you the screen, you hit enter. So it's a little bit less typing maybe than typing this because tab completion will still work. So if I type git tab, tab completes all of git's commands. But that's, as far as branching, that's the only actual help that you get. I think if you're looking in the git log, sorry, the git log that's long, no, it doesn't have any. It doesn't mention any branching there either. So it lets you see branches only and not in as much as you would with a normal command line. But that said, you could diff between branches. So the easiest thing is I know this makefile exists in the other branch, so I'm just gonna like delete all of it. And if I actually want to do a specific diff between master and head, because this is not committed, then I could do that. Oh, but I did the syntax wrong. You actually don't need both arguments. So if I wanted to get this against master, that's what I would need to do, and I get that convenient thing. I think that this buffer, yeah, you can't edit. Actually, I'm not sure what happens if you edit in the readable branch. Yeah, you can't make changes to it. So the buffer that's that represents another branch that you're not in is write only, or is read only. But you can still do things, for instance, like use diff put to copy everything back over into your branch. So in one way, you could use this to merge changes between branches without having to, type things on the command line. You just type things in them, and it's a bit more context aware. Another thing that really is handy that comes up sometimes is renaming files or moving files that you're actually editing. So if I want to name this makefile.am, for instance, if I did that, everything changes. The file physically gets moved, the buffer name gets updated, and that actually, this does those two things. So if you just move the file, if I move this file back, and I just did the shell command, we'd be in a really bad situation because our file name hasn't changed. The Vim knows about. So if you were going to write this, it would create the original file name. So, any other questions? Questions are good. Questions drive the plan to talk.
Your question, like Subversion, you have kind of a recommended layout for the repository. Does Git have something like that?
Your repository should be laid out just based on what the project is. You should have one thing. I think what you're asking is, in Subversion, you keep multiple projects in one Subversion repository sometimes, right?
That, but you also have like a branch, a tag, and a...
Yeah, those aren't concepts that exist in the file system. So I can explain that pretty simply. So we already are on a branch called test, which on my shell you can see in parentheses. And there are other branches. Well, there's one other branch. And those, if you change branches, you're changing the contents of the working directory. Do I have that slide stuff? So when you change your branch, the working directory changes, but the index doesn't change. So if you are getting ready to add a file, we'll go back to the to-do list example.
When you say the directory changes, are you saying stuff that's part of the repository changes or stuff that's?
I'll show you in a second. So if I was adding this file, if I was partway between adding this file, I've added to-do.list, and that's now in the index, and I decided that I didn't want this to be on test, and I haven't committed it yet, it'd be very simple to just go to the master, and now the file is both files are still modified in the thing, and the file is still here. But if I were to go to test, and we're gonna actually commit those changes first, just so they're out of the way. By the way, don't ever use commit messages like that outside of the talk. It makes you a mean person. Probably will make other people mean as well. So we want to remove the makefile, and the makefile is now gone. But what I mean by files change is files in the working directory will change when you change branches. Because now, I didn't commit that change yet, so I gotta do that. Look at me figuring, I think I was in a different directory. So now that I've removed that and committed, if I were to go to a different branch that still has it, it would still be there. Now, it gets into an interesting situation. If changing to a branch would result in a file possibly being different, like we're to have this checked out on test now, we change the to-do list in test, and someone else changes the to-do list in master, and without committing it yet, and you change branches over, you'll probably get a merge error, or it won't be able to complete. I think actually you won't be able to complete switching branches because there will be conflicts. You can actually generate that error fairly trivially. But so, and what you're coming from is in Subversion, and other people that might not know, is in Subversion, you have a single repository, which is like a file system, and there's a convention that you have. So you have your trunk, you have branches, I think it was usually named plural, and you have tags. None of these things exist in the file system in Git. The structure just isn't there. The structure is whatever the files themselves are, and all of this stuff is kept in